Hello guys, today we're going to be solving the May-June 2025 Paper 12 CIE Chemistry paper. Question number 1 asks us to consider the following statements and to select which ones are correct. So statement number 1 states that silicon dioxide has a higher melting point than sulfur dioxide. The formula for silicon dioxide is SiO2 and the formula for sulfur dioxide is SO2. Now, what is expected of us is to recognize that silicon dioxide is a giant covalent, while our sulfur dioxide is a simple molecular gas. Therefore, silicon dioxide definitely has a higher melting point than sulfur dioxide due to the presence of many strong covalent bonds. The second statement says that ammonia has a higher boiling point than phosphine, which has the formula pH3. The formula for ammonia is NH3. Both of them have 3 hydrogens, so what they expect of us is to recognize that there's an N here and a P here. The N here means that there is hydrogen bonding due to the presence of hydrogen atoms being bonded to one of the following, F, O, or N, so fluorine, oxygen, or nitrogen atoms. In pH3 or phosphine, there is none of that, so in ammonia you'd have hydrogen bonding, and in pH3 you'd have dipole-dipole forces. So, as we know, hydrogen bonding is a lot stronger, therefore ammonia has a higher boiling point, meaning that both statements are correct, and the correct answer is A. Question number 2 asks us to find how many neutrons would be contained in an atom of iron with a mass number of 60. If we look at our periodic table, we find that iron has an atomic number of 26. So if we have a mass number of 60, the number of neutrons plus protons gives us our mass number. So in order to find the number of neutrons, we would have to subtract 26 from 60, and we would end up with 34 neutrons. Therefore, the answer is C. Question 3 shows us a Boltzmann distribution diagram of molecular energies for a gaseous reaction at 2 different temperatures and 2 different activation energies. It's asked us to find the combination that will give us the highest reaction rate. The highest reaction rate would generally have these 2 conditions, a high temperature and a low activation energy. Temperature, because higher temperature means more kinetic energy of the colliding particles, therefore more successful collisions, and lower activation energy would mean less energy required for success. If we look at our graph, we can easily identify which activation energy is lower. It is EA1 because it comes before EA2. Now for temperature, we see 2 different curves. Now, T1 has a higher peak, but that shouldn't throw you off. In reality, both curves have the same area under them. The T2 graph, however, has a peak at a higher energy, which means, on average, more particles in the second curve, in the T2 curve, have greater energy than the average energy of particles in the T1 curve. Therefore, T2 is our greater temperature. So, combining T2 and EA1 would give us the highest reaction rate. Therefore, the answer is D. Okay, question 4 has given us an equation and would like us to find the correct statements. The reaction equation is between sulfur dioxide and oxygen to give sulfur trioxide. It has a delta H of negative 197 kilojoules per moles, which is a negative enthalpy. Therefore, it is an exothermic reaction in the forward direction. It says that there was 1 mole of sulfur dioxide and 1 mole of oxygen in a closed container, and they were heated to a constant temperature, and at this temperature 0.8 moles are present in the equilibrium mixture. Our ICE table, so I stands for initial, C for change, E for equilibrium. So initially we have 1 mole of sulfur dioxide, 1 mole of oxygen, and 0 moles of sulfur trioxide, because unless mentioned, we assume that none of these have reacted initially. Then it states that we have 0.8 moles of sulfur trioxide at equilibrium, and now we know that there's a change of 0.8 moles from 0 to 0.8. And because sulfur dioxide and sulfur trioxide are in a 1-to-1 ratio, so 2 to 2 are both divisible by 2, so a 1-to-1 ratio, Therefore, there is also a change of 0.8 moles. And because there is a 2-to-1 ratio between sulfur dioxide and oxygen, there must have been half the change, so 0.4 mole change for oxygen. Because sulfur dioxide and oxygen are reacting, they will eventually decrease in amounts so that sulfur trioxide can increase. So really, at equilibrium, we'd have 1 minus 0.8 moles, which is 0.2 moles of sulfur dioxide, and we'd have 1 minus 0.4 moles, which is 0.6 moles of oxygen. Now we can take a look at our statements to see which one is correct. So option number A states that the partial pressure of sulfur dioxide is greater than the partial pressure of oxygen at equilibrium. So our partial pressures are equal to our mole fractions times our total pressure. To find the mole fractions of each, we need to find the total number of moles at equilibrium, which is equal to 0.2 plus 0.6 plus 0.8, which will give us 1.6 moles. Therefore, at equilibrium, our mole fractions for sulfur dioxide would be 0.2 over 1.6. For oxygen, it would be 0.6 over 1.6. And for sulfur trioxide, it would be 0.8 over 1.6. So the higher the numerator of a molar fraction, the higher the partial pressure is going to be. But as you can see, oxygen has a higher partial pressure in this case because it has a larger numerator. So automatically, when we carry out the calculations, when we do calculate the partial pressures for each, we'll find that oxygen actually has the higher partial pressure. Therefore, A is definitely incorrect. Option B says that Kp has units of moles per decimeters cubed. That is definitely wrong because moles per decimeters cubed is a unit of concentration and it can be used in Kc. Kp actually uses partial pressure units such as Pascal or kilopascal, etc. Okay, so and then option C says at a lower temperature the equilibrium amount of sulfur trioxide is lower than 0.8 moles. Well, that is incorrect because we have an equilibrium reaction. And at the start, we did say that it is exothermic in the forward reaction. So if we decrease the temperature, we will have the equilibrium shift to the right to increase the temperature, because when we shift it to the right, we'll have more exothermic reaction taking place, so increased temperature to oppose this change. Therefore, we would actually end up with more sulfur trioxide, so greater than 0.8 moles. Therefore, the answer must be option D, and option D states that the mole fraction of SO3 is less than 0.8. It is 0.8 divided by 1.6, so indeed, this is equivalent to 0.5. As its mole fraction, therefore, it is less than 0.8, and the answer is indeed D. Question 5 states that red lead is a red pigment with the following formula, Pb3O4. So we have 3 lead ions and 4 oxide ions. Every formula unit of red lead is the same, and lead has 2 different oxidation states within red lead. So what are these oxidation states? Okay, so I'm just going to rewrite Pb3O4. So this is a compound. It is neutral. It has no charge. And we know for a fact that oxygen atoms always have an oxidation state of -2. If we have 4 of these, the overall oxidation state for this part of the compound is -8. To balance that out and have an overall charge of 0, these Pb3s must have an oxidation state of +8. So we have 3 Pb ions, and they have 2 different oxidation states. So 2 will share 1, and then the third one would not share the oxidation state with the rest, so they end up with +8 as their oxidation state. So we need to look at our options for this. Option number A suggests that the oxidation states involved are +1 and +2, but this can't be the case because even if we had 2, 2, 2, which it's already told us that there are different oxidation states, we'd only end up with 6, +6, so it's definitely not A. Option B states +1 and +3. So if we give 2 the 3 one and 1 the 1 one, we'd end up with 7. Okay, and if we did 2 with the 1 and 1 with the 3, we'd end up with 5. So there's no way that these are the 2 oxidation states. So it's definitely not B. If we look at number C, let's give 2 of them the +2 and 1 the 4. We would end up with 8. So there you go, it must be C. However, if we want to double check, if we have +6 for 2 and then 1 for 2, you'd get a 14. It's not going to work. 2 2s and a 6, you're going to end up with 10, and that's not going to work. Therefore, the answer must be C. Okay, question 6 has given us a table with standard enthalpies of combustion data, and it's asking us to use this data to find the enthalpy change of formation of methanol. So methanol has the following formula of CH3OH. Now, the equation of any molecule must consist of the molecule being formed and only 1 mole of it being formed from its constituent elements, so from the individual atoms that make up the molecule. So we have carbon, hydrogen, and oxygen. And it's given us the data for these. So carbon has a enthalpy of combustion of -394. Hydrogen has a negative enthalpy of combustion of -286. And methanol has one of -726. The arrows are pointing down because it is a Hess cycle of combustion. And we produce CO2 and H2O when we combust. But we know that to find the enthalpy change, we must go in the direction that this arrow follows. So these 2 arrows go down, they follow the pathway, but this arrow is going against it. So we're going to have to multiply this one by -1. So what we're going to do is we need to remember that there's 2 of the hydrogen as well. So really, the enthalpy change of formation is equal to -394 plus 2 times -286 minus 726. And then we end up with -240 kilojoules per mole. Therefore, the answer must be A. Question 7 has a table of bond angles, and it's asking us to find which row is correct. So basically put these in order. So we have 3 molecules, H2O and H3 and BF3. So you need to be able to draw out these molecules in order to determine the bond angles. So I've already drawn them out, but we're going to go through how to actually get to this drawing to begin with. So first of all, you're going to take your central atom, which is oxygen, and you're going to find which group it is in, which is group 6. Then you're going to find the bonding atoms, the number of them, and there's only 2 hydrogen atoms bonding. Therefore, in total, we'll have 8 bonding pairs because we've added them both up. We have no charges, so there's nothing to do with that. And then we have to divide our bonding pairs by 2 because each electron pair has 2 electrons. So in total, we'll have 4 bonding pairs. If we have 4 bonding pairs and we only have 2 bonding atoms, therefore 2 of our pairs are going to be electron pairs. So naturally, it would take this form. Now, this is what we call the bend shape. The bond angle, however, so there's 4 bonding pairs, 2 are lone. So, 2 bonding pairs, 2 lone pairs. Naturally, this shape, because it would usually be tetrahedral, it would have a bond angle of 109.5. Okay? However, because there is lone pairs, they decrease the bond angle by 2.5. So really, our bond angle is going to become 104.5. Okay? For the next NH3, or ammonia, as we call it, the central atom is nitrogen. Nitrogen is present in group 5. We have 3 bonding atoms, 3 hydrogens, and that gives us a total of 8 bonding pairs. And divide that by 2 to give 4. So there's 4 pairs in total. However, there's only 3 bonding atoms, so 1 lone pair. And we end up with this shape. Again, it would be 109.5, but if you subtract 2.5 degrees due to electron pairs being more repulsive, we'll end up with 107 degrees, okay? So then we take a look at BF3. The central atom is boron. It is present in group 3. There are 3 bonding atoms, so 3 total of 6 divided by 2, we end up with 3 bonding pairs, 3 bonding atoms. We have our simple trigonal planar molecule or shape. Therefore, each bond angle will be 120. So if we compare these, BF3 has the largest bond angle, so it's between A and C, whilst water has the smallest bond angle, therefore the answer must be A. Okay, so question 8 states that in the Haber process we have two gaseous reactants that require the use of a catalyst. They want us to determine which metal is the catalyst and in which molar ratio do the gases react. So we know in the Haber process we create ammonia from its constituent elements nitrogen and hydrogen. Naturally, you can see there are two nitrogens on the left hand side, so we'd multiply the right hand side by 2 so that we could end up with 2 nitrogen atoms on the right hand side. Then we end up with a total of 6 hydrogens on the right hand side, so we would multiply the hydrogens on the left hand side by 3. Therefore, these two are reacting in a 1 to 3 molar ratio, and it's something we should have memorized that iron is our catalyst for this reaction. Therefore, the answer must be B. Question number 9 states that aqueous hydrogen peroxide decomposes into water and oxygen in the presence of a suitable catalyst. Have this number or amount of volume and concentration of hydrogen peroxide, and this volume of oxygen is produced within 2 minutes. The volumes of gas was measured at room conditions, and they're asking for the average rate of decomposition during this 2-minute period. Okay, so the first thing we're going to do is we're going to find the moles of oxygen produced. It says that 120 centimeters cubed. If we look at our units in our options, it's using decimeters cubed, so I'm just going to convert that by dividing by 1,000, which will give us 0.12 decimeters cubed. Now, if you look at the equation for hydrogen peroxide decomposition, you know that hydrogen peroxide and oxygen are in a 2 to 1 ratio, which means whatever moles our oxygen is produced, double the amount of hydrogen peroxide was decomposed for it. So since our gas is measured at room conditions, we know that 1 mole of gas is equal to 24 decimeters cubed. Therefore, 0.12 decimeters cubed divided by 24 decimeters cubed will give us our number of moles, so 0.05. Therefore, the moles of H2O2 decomposed are equivalent to double that number, which would give us 0.01. Now, we have the number of moles of hydrogen peroxide decomposed, but remember our units are in moles per decimeters cubed, so they want the concentration. And at the beginning, they stated 50 centimeters cubed of this hydrogen peroxide solution was used. Therefore, our concentration, which is equivalent to our number of moles divided by our volume, hydrogen peroxide would equal to 0.01 divide 50 divide 1,000, which is 0.05, which would give us 0.2 moles per decimeter cubed. And in a 2-minute period, and our units being in seconds, we'd have to convert 2 minutes to seconds. So 2 times 60, which equals 120. Therefore, 0.2 divide 120 gives us 0.00167 moles per decimeters cubed. And this can round up to 0.0017 moles per decimeters cubed per second, which would mean our answer is C. Question number 10. The average intermolecular forces in water are much stronger than those in steam, and the average intermolecular forces in ice are slightly stronger than those in water. So I've just written this out to sum that up. And it says enthalpy changes are associated with equilibrium processes shown. Which of the following statements are correct? Okay, so let's just take a look at these two equations to begin with, okay? So what do we have going on here? Here we have in the first equation from liquid to gas. So this is known as boiling or vaporization. And in the second equation we have solid, water, so ice, going to liquid, which is known as melting. So they've denoted it, so they've done HB, so B for boiling, M for melting. And it says, it's given us 3 statements. So statement number 1 states that both net enthalpy changes are negative. Negative would imply they're exo, but as a matter of fact, both of them are endo, because if we take a look at this, if there are stronger intermolecular forces in liquid than there are in gas, then we're weakening the intermolecular forces. There won't be a release of heat energy. Instead, there'd be more energy needed to break the bonds apart because we're getting the molecules or the particles to be further away from each other. Statement number 2 states that HB is greater than HM. Now this statement is correct because if you think about it, going from liquid to gas requires a lot more energy than going from solid to liquid because you're completely separating the molecules. And if we look at option 3, it says intermolecular forces in ice and water are of the same type. This is also true. They both have hydrogen bonding. Now, the hydrogen bonds in ice are slightly stronger on average, but they are still the same type. Therefore, both statements 2 and 3 are correct, and option D must be the correct answer. Question 11 states that an experiment was carried out to determine the value of X in lithium hydroxide solid, hydrated solid, my bad. This solid was heated in a crucible over a Bunsen flame. Complete dehydration did take place, and these are the data that they came up with. They used variables, and they want us to find the correct value of X in terms of these variables. So let's take a look at what's going on. So we have the mass of an empty crucible is Q. Then we have the mass of the crucible plus the hydrated solid, which has a mass of R. Then we heated it, and we got rid of all of that water, and then we end up with the solid alone with a mass of S. Okay, so what does this mean for us? The mass of the hydrated solid is equal to R minus Q. That's M for mass equals LiOH dot XH2O. The mass of our anhydrous LiOH is equal to S minus Q. Because obviously we need to deduct the mass of the crucible. The mass of water lost would be R minus S, because that is when water had left. Now, I've written the MRs of each of these because they are basically just the sum of the atomic MRs that you can find in the periodic table. Just to speed things up a little bit, I have just put them up there. So really we know that moles equals mass divide MR. We can find the moles for each of these. The moles of water would be equal to the mass, which is R minus S, divide its MR, which is 18. The moles of LiOH would be equal to its mass, divide its MR. Now that we have the two moles, by definition, X is equal to the moles of H2O divide the moles of LiOH. Because remember, they are in a ratio, a 1 to X ratio. So really, if we take these and substitute them, we're actually going to end up with option number C. R minus S divide 18 divide S minus Q over 23.9. Really, to divide these two, we just have to flip this one upside down and multiply by it. So it's really equal to R minus S over 18 times 23.9 over S minus Q, and that would result in 23.9 times R minus S over 18 times S minus Q, which indeed is option C. Compound M is a white solid, and it is a chloride of the period 3 elements. Information about the reactions are shown in the table along with the observations, and we have to figure out what compound M is. So it's already given us that it is a period 3 chloride, so it's either sodium chloride or perhaps MgCl2 or AlCl3 or PCl5. There isn't anything we can exclude from the options because those are the options that they have given us. It has stated, compound M, when added a little at a time to water, causes steamy fumes Q and colorless solution R. Now this would mean that either we have AlCl3 or PCl5, because if you think about it, when these two are added to water, they either form AlOH3 plus HCl, or they form H3PO4, the acid, plus HCl. Now, the reason why we've picked these two is because neither NaCl nor MgCl2 would dissolve in water. Okay? Down here, it says the fumes of Q are tested with moist blue litmus paper and it turns red. So that means the fumes are coming from an acid, which makes sense for both of these. Then it says solution R plus a few drops of sodium hydroxide are added, and then excess sodium hydroxide is added. First, a white precipitate is given, then it dissolves to form a colorless solution. From this, we can already tell you that it is aluminium chloride. The reason for this being is it goes from a white precipitate in limited NaOH, and then it dissolves in excess. However, PCl5 gives phosphoric acid, and then sodium hydroxide would just neutralize this acid. It wouldn't give a white precipitate that re-dissolves. Therefore, our answer is option A. Option 19 wants us to select the correct statement about strontium and its compounds. So really, we are just referring to group 2 by just taking a look at these options. So the first statement states that strontium hydroxide is more soluble than barium hydroxide. This is actually false. Why? Because hydroxide solubility increases, which means that it is actually less soluble than barium hydroxide, okay? If we take a look at option number B, strontium sulfate is more soluble than magnesium sulfate. No, actually, it's the other way around. There's an opposite trend with hydroxides and sulfates. Sulfate solubility decreases as you go down the group, so it is actually less soluble. Then option 3 states that strontium nitrate has a lower thermal stability than calcium nitrate. This is again false, because nitrates actually, the thermal stability of nitrates increases as you go down the group. Therefore, strontium nitrate would actually have a higher thermal stability than calcium nitrate. So that would leave us with option D, and that is strontium is a stronger reducing agent than magnesium. This is because as you go down the atomic group, you lose electrons more easily, because really what is happening is your shells are increasing, so less electrostatic forces between outer electrons and the positive nuclei. Okay, so question 20 states that sodium bromide is warmed with concentrated sulfuric acid, which row describes the oxidation number of sulfur change, or the change in the oxidation number, and the role of bromide ions in the reaction. Okie dokie, so when we have sodium bromide and concentrated sulfuric acid, we end up forming hydrogen bromide. This hydrogen bromide can further react with the sulfuric acid to produce other compounds such as bromine, sulfur dioxide, and water. In this second equation, bromide ions reduce sulfur. Now, a known feature about bromide ions is they're reducing agents. I can already exclude options A and C, but we can even prove this ourselves. So if we take a look at sulfuric acid, we know that hydrogen atoms have an oxidation state of +1, and since it's 2 overall, +2. And oxygen atoms have an oxidation of -2, but since it's 4, there's an overall oxidation state of -8. Now this is a compound, it has no overall charge, so +2 plus x minus 8 must equal 0, therefore x must be +6. So in sulfuric acid, sulfur has an oxidation state of +6. Now in sulfur dioxide, which is what is produced after a hydrogen bromide further reacts, has an oxidation state of +4, because oxygen would have an overall oxidation state of -4. So we've gone from +6 to +4. Therefore, it's gained electrons, so it's been reduced. And the reducer is bromide. It has reduced sulfur, so it acts as a strong reducing agent. So the answer to this question must be option B, for it has the correct change and the correct role. Question number 21 states that a reaction between ammonium chloride and calcium hydroxide occurs. What is the role of ammonium ions? Okay, so this is the actual equation of what takes place, and this is the ionic equation for it. And this is our ammonium chloride, and this is our calcium hydroxide. So you know that the ammonium ions in ammonium chloride carry a charge of +1, and hydroxide ions in calcium hydroxide carry a charge of -1. So really, what is taking place here? We go from hydroxide to water. We gain a hydrogen, and ammonium ions lose their hydrogen. So what's happening here is ammonium ions are donating hydrogens. The donation of hydrogen is a characteristic feature of acids. Therefore, ammonium ions are acting as an acid. Okay, question 22 has given us anonymous elements Y and Z. It's stated that they're both in period 3, element Y having the smallest atomic radius, and that there are only 2 elements in period 3 that have a lower melting point than element Z. They both react together and form compound R. What could compound R be? Okay, so first of all, let's identify element Y. It says it has the smallest atomic radius. For period 3 is chlorine, the chlorine atom. Our atomic radius decreases as we go across the period, ignoring unreactive argon because it doesn't really form compounds generally. The second one, element Z, said that only 2 elements have a lower melting point than it. As you go across period 3, the melting point actually decreases. So the only atom in period 3 that would have 2 elements with lower melting points than it would be phosphorus. Therefore, we'd end up with PCl3, therefore the correct answer is D. But I just want to clarify something real quick on the melting point concern. So from sodium to aluminium, these are metallic structures. So the melting point increases across these 3 because there would be more delocalized electrons as the charge increases. So we'd have an increase in melting point here. Then we have silicon, which forms silicon dioxide and is a giant covalent. So this would have a really high melting point. And then from phosphorus to sulfur to chloride, these are all simple molecular, and they're really just small molecules held together by van der Waals forces. So what would happen here is the number of electrons would actually decrease as you go across, and the size of the molecule decreases as well, and so the van der Waals forces get weaker, and so does the melting point. Question number 23 states that 1 gram of each of the 4 different compounds of group 2 elements are thermally decomposed. The residue is the oxide of the group 2 element. The volume of gas produced from each is measured at room conditions. Which substance produces the greatest volume of gas? So we have a collection of carbonates and nitrates. Now, I've wrote out the equation for the decomposition of carbonates and for nitrates. So carbonates would produce 1 mole of carbonate produces 1 mole of gas, 1 mole of carbon dioxide. And 2 moles of nitrates produces 5 moles of gas, because obviously nitrogen dioxide and oxygen are both gases. So it's 1 to 1 for these guys, it's 2 to 5 for these guys. Now we need to calculate the moles of each solid in 1 gram. So we've taken these options A to D, and I've just wrote down the MRs to save us time, but the moles of calcium carbonate would be 1 divide 100, which is equal to 0.01, and then 1 divide 148 is equal to 0.0068. Then we have calcium nitrate, which is 1 divide 164, which is equal to 0.0061, and then the moles of strontium nitrate would be equivalent to 0.0047. So now that we think about it, we'd get these 0.01 moles for these carbonates and for this carbonate, and then 0.0068 moles for strontium carbonate. How? Because there's a 1 to 1 molar ratio. However, for our calcium nitrates, we'd have to times by 5 and divide by 2 for both of them to find the moles of gas produced. So we'd get 0.015 moles of gas produced in this one, and we'd get 0.012 moles of gas produced here. Amongst all of these, the highest number of moles is in here, calcium nitrate, thus the largest volume. So our option or our answer must be option number B. Question number 24 states that sulfur dioxide in the atmosphere can form acid rain, and this occurs in 2 steps. First of all, sulfur dioxide is oxidized to form sulfur trioxide, which then forms dilute sulfuric acid. It wants us to identify the catalyst for the oxidation and the reagent for step 2. Okay. So, acid rain is a common consequence in cars because nitrogen can actually react with the air to form nitrogen dioxide because of the very high temperatures in engines. And as a result, nitrogen dioxide can actually react with sulfur dioxide to form sulfur trioxide, acting as a catalyst. So we can already cancel out options A and B. Now, acid rain is basically acid, and in this case, it's sulfuric acid. To get sulfur trioxide to form sulfuric acid, the main difference is the hydrogens. It wouldn't make sense for the reagent to be oxygen because where are we getting the hydrogen from? Therefore, it must be water, so the option or answer is C. Question number 25 is asking us to select the statement about a mechanism of SN1 reaction of a halogen or alkane. That is correct. Okay? So, option A, a nucleophile is substituted by an electrophile. That is definitely incorrect. Nucleophilic substitution is when a nucleophile attacks. An electrophile does not replace anything. Option number B states that one intermediate is formed from 2 reacting molecules. The intermediate carbocation that isn't formed from 2 reacting molecules. It's formed from 1 molecule, the halogenoalkane. That is why it is unimolecular. That's why it is SN1. So this is incorrect. C, the intermediate is stabilized by adjacent alkyl groups. That is correct. The carbocation that is produced is stabilized by alkyl groups. And this is why tertiary halogenoalkanes undergo SN1 most easily because they have so many alkyl groups attached to the carbon atom. The answer must be C, but let's just take a look at D. The intermediate is uncharged. No, it's not. It's a positive carbocation. So, question number 26 shows us a repeating unit of a polymer, and it's given us 3 statements, and we have to find which ones are correct. Statement number 1 states that its disposal is hazardous because it produces toxic gases when burned. True, because we can see chlorine, and we can assume that HCl fumes will be produced, which are toxic. 2 says there are 2 different monomers that are used to make this polymer. This is also true. As you can see, it doesn't repeat the Cl atom. There's clearly there's this part of this is the first monomer and this being the second because the Cl does not repeat and instead there's an OH group as well. The third one states that the monomer for this polymer is 3-chlorobute-2-ene-1-ol. This, however, is incorrect because the double bond is between carbons 3 and 4 and not 2 and 3. Let's just dive a little deeper into this. So this would suggest that, let's draw out 3-chlorobutene-ol. So okay, that would suggest that the OH and the Cl are adjacent to each other, but they're not. Thus, that means option number 3 is wrong. Therefore, the correct answer is option A. Question 27 has stated that methanoic acid has acidic properties and it can also additionally be oxidized by the same oxidizing agents that are capable of oxidizing aldehydes. Which pair consists of 2 compounds that will give the same observations with Fehling's reagents? So it has methanoic acid in each of our options and then a different companion compound, I guess. So I've just basically written next to each option what the second compound really is. So the first one is ethanoic acid, second ester, third ketone, fourth aldehyde. The only types of compounds that react with aldehyde, with Fehling's reagent, are aldehydes, and we've also been told that methanoic acid also would react with Fehling's reagent. Therefore, the only answer can be D. Question 28 asks us to find which row would give pentane nitrile as one product. So it's a bunch of bromoalkanes, and we need to find which one would give us our pentane nitrile. So first of all, the reagents required and the conditions are ethanol as a solvent and heating with KCN. So we can already scratch out A and C. Then we have to find which molecule, which halogen or alkane will give us pentane nitrile. So we can count to see the difference. 1, 2, 3, 4, 5 carbons in this one, and 1, 2, 3, 4 carbons in this one. Now pentane nitrile has 5 carbons, but we can't forget that the nitrile, or the KCN, which gives us that nitrile, also has a carbon. So we must have 4 carbons to begin with, so that when we add the CN, we end up with 5 carbons in the nitrile. That must mean that the answer is B. Okay, so question 29 states that an ester is hydrolyzed in alkaline conditions. It consists of 2 different alkyl groups, which were identified as the 2 products. So hydrolysis under alkaline conditions is also known as saponification. Basically, what happens is the hydroxide ions in the ester react to form a carboxylate ion and an alcohol. So these would be our products. We can cancel out C and D because there's no alcohol product mentioned. And it's definitely not A because a carboxylic acid is not formed because the strong base immediately deprotonates it. So we'll always end up with a carboxylate ion. So the answer must be B. Question number 30 states a compound cannot be oxidized by acidified potassium dichromate, an oxidizing agent, but does react with sodium metal. Which of these is a compound? So there are only 2 things that cannot be oxidized, that is tertiary alcohols and ketones. I can already exclude C and D because they are primary and secondary alcohols. However, A is a tertiary alcohol and B is a ketone. They've also mentioned that it reacts with a sodium metal. Ketones do not react with sodium. Alcohols do to produce hydrogen gas. Therefore, the answer must be option A. Okay, so question number 31 states that butan-2-one reacts with alkaline iodine, and an excess of dilute sulfuric acid is then added to the mixture. The organic products are triiodomethane and a product M. What is product M? So this is the formula for butan-2-one. This first half, the CH3CO, will go on to form the triiodomethane. The rest, the CH2CH3, forms the propanoate ion, and since there's an excess of dilute sulfuric acid, hydrogen ions will be donated to this propanoate ion to form propanoic acid. So product M is propanoic acid. Question 32 lists 4 reagents. Which of these reagents, when added to ethanol, will produce a gas that turns blue litmus red? So blue litmus red indicates it's an acidic gas that is produced, and this reagent must react with ethanol. Okay, so when KCl reacts with an ethanol, no gas is actually produced. We already cancel options A and B out. With dilute HCl, no gas, again, is produced. With liquid SOCl2, we end up with SO2 and HCl gas. This HCl gas is going to turn blue litmus red. PCl5 is a solid, and it would also produce HCl alongside POCl3 and chloroethane. Therefore, both options 3 and 4 are correct, and the correct answer is option D. So question 33 states that 4 drops of 1-chlorobutane, 1-bromobutane, and 1-iodobutane are separately put into 3 tubes containing 1 centimeter cubed of silver nitrate at a particular temperature. In each case, a hydrolysis reaction takes place. They've given this equation where R represents C4H9 and X represents the halogen atom, and they've stated that the rate of formation of cloudiness in the test tubes is as follows. So the 1-iodobutane hydrolyzed the fastest, and the 1-chlorobutane hydrolyzed the slowest. And it's asking us why this is. So option A states that the boundary energy of Rx decreases from RCl to Ri. That is correct. So as the bond energy decreases, it's easier to break. Therefore, 1-iodobutane is able to hydrolyze the fastest because it has the weakest bond. So option A is correct. Then if we take a look at option B, it's on about ionization energy. However, ionization energy doesn't have much to do with this. Then option C talks about solubility. However, solubility really just affects how visible a precipitate is rather than how fast something hydrolyzes. And last but not least, option D talks about bond polarity, but it's not about polarity, it's about strength. So really, they are all true statements, but only A is relevant to Y. Question number 34 states that propanoic acid reacts with LiAlH4 to give an organic product. This product then reacts with methanoic acid in the presence of concentrated sulfuric acid to give a second organic product. What is the skeletal formulae of these two organic products? Okay, so LiAlH4 is actually a very strong reducing agent that reduces carboxylic acids into primary alcohols. So we end up with a ethanol alcohol. Therefore, option C and D are definitely not correct because we don't end up with an alcohol in this case. Now, this next reaction that takes place is between an alcohol, methanoic acid, a carboxylic acid, and concentrated sulfuric acid. So, when you have concentrated H2SO4, and you have an alcohol, and you have an acid, what occurs is esterification, which forms an ester. Esters have this functional group. Therefore, the only correct answer can be A, as you can see right here. Okay, so question number 35 states that these two samples of CH3Cl and Cl2 gases are mixed together under UV light. Which compounds are produced by the termination step? Remember, the termination step is when two radicals combine to form a non-radical. So here I've set out the initiation is the chlorine initially breaking down to form two free chlorine radicals, and then propagation is when a non-radical and a free radical combine to form a non-radical and a free radical. And in the termination step, of course, the free radicals can then join to form a single non-radical product. So really, the non-radical in this case, or the free radical, that forms during the propagation step is CH2Cl, and two of these would form option C, CH2Cl, CH2Cl. So the answer would be option C. B is incorrect. No alkenes are formed. HCl is not in the termination step, it's in the propagation, and H2 is incorrect as well. Okay, so question 36 states that propanol is dehydrated by passing it over a hot aluminium oxide, to give a hydrocarbon. Which structural formula represents the product obtained when this hydrocarbon reacts with bromine? So, hot aluminium oxide and alcohol equals elimination reaction. This would form an alkene. Alkenes undergo nucleophilic substitution when they react with bromines. The carbon-carbon double bond is broken, and you get 2 Brs on each carbon because each carbon needs 4 atoms to bind to it. Therefore, the answer is option D. Question number 37 states that alkane S has a formula of C4H10. It reacts with chlorine in the presence of sunlight to form two different monochloroalkanes with this formula. Both of these are treated with hot ethanolic KOH to produce the same alkene and no other organic products. What is produced when this alkene is treated with hot concentrated acidified KMNO4? Okay, so given that alkane S has C4H10 and it produces two different monochloroalkanes, it's safe to assume that this is 2-methylpropene. Because as you can see, it would give these two different variations of monochloroalkanes. Now it's said that we've treated these monochloroalkanes with KOH, ethanolic KOH, and we produced an alkene. The alkene that it forms is as follows, and this alkene is then treated with hot concentrated acidified KMNO4. So basically what happens is this CH2 will actually go on to produce CO2 upon oxidation, and then the remainder of this molecule will go on to produce a ketone, CH3, COCH3. Therefore, the correct answer must be B. Question number 38 asks us to find the number of isomers of C2H2Br2, whether they be structural or stereoisomers. So there are actually only 3, so option B is correct. There's the structural isomers of this. So 1,1-dibromoethane, and then there's the cis and trans isomers of 1,2-dibromoethane. Okay, question number 39 asks us which compound exhibits stereoisomerism. There is two conditions. One, a carbon-carbon double bond. Two, different groups are attached to the carbon-carbon atoms in the carbon-carbon double bond. So option A, we have 1,1-dichloropropene, but see here, there's two hydrogen atoms attached to the carbon in the carbon-carbon double bond, therefore that won't exhibit stereoisomerism. We have option B, which is our correct answer, and it does because, as you can see, there's a Cl group and a H3C group on one carbon atom, and there's a H group or a hydrogen group and a Cl atom attached to the second carbon. Therefore, we can get this first one a cis and the second one a trans isomer. Options C and D are incorrect because they are alkanes and not alkenes, therefore there is no double bond to begin with. Question number 40 states that the mass spectrum of CH3Cl has a molecular iron peak of M+ at Me value of 50 with a relative abundance of 18%. Other peaks are also present in the mass spectrum. What can be seen at the mass spectrum at Me value of 52? Okie dokie. So first of all, we need to identify where this 50 peak is coming from. Remember that the Cl atom has two isotopes, the 35Cl and the 37Cl. The 35Cl is more abundant. It occurs in 75% of all chlorine atoms. And 37Cl occurs in 25%. So the molecular mass of CH3 is 15. So to get that 50 peak, we must have had 35 Cl, because 35 plus 15 will give us 50. And this 52 peak that they're on about here must be the 37 Cl. So if the abundance if the value of 50 arised with the 35 Cl, and the value of 52 arise with the 37 Cl, and we had an 18% relative abundance here. All it is a matter of ratios. To find the relative abundance of 37, we just do 18% times 25 over 75. We just cross multiply, right? And then we end up with 6%. So the relative abundance at this peak is 6%, which is option B.